Lide. He's from Reno here. I'm sure a lot of you know him. Chet got his bachelor's degree in geology from the University of Tennessee and an MS degree from the Mackey School of Mines here in geophysics. His past mineral exploration activities involved working for Union Carbide and Falconbridge Copper, and then he started Great Basin Geophysical, which turned into Zonge International here in Reno, which he's still currently working with. So let's see, the title of his talk is Geophysical Exploration at the Altan Nar Project in Mongolia.
Thanks a lot. I'm going to talk about basically a case history of integrated exploration at the Altan Nar Project in Mongolia. I'd like to thank my co-authors and cohorts from Erdene Resource Development. They provided the geological input and hired me. I'd also like to thank the guys on the ground, Chris Cowan, Erdene, and Peter Dalton. Runge, Pincock, Monarco did a resource assessment, and I've stolen a lot of their figures. I'd like to say thank Taronish Ithwala at Geosoft for helping me through some boxy magnetic inversions. And last but not least, our partner in Mongolia, Erdene Arel, and the guys in the field. Okay, just on the front end here, I'm going to present an integrated exploration program. Our focus was on shallow, bulk mineable targets. This was basically, in basketball terms, a run and gun program, but we needed very good shot selection. By the way, if you're going to try to follow in the book, I'll warn you, there's not a great correlation. This integrated program resulted in the 2011 discovery of a polymetallic gold, silver, lead, zinc epithermal system. Currently 2 resource areas are being defined, Discovery Zone and Union North. And we have a high success rate for scout drilling on multiple additional targets. And at the end of it all, IP chargeability from the geophysical end of things was the most direct indicator of mineralization in this system. Okay, there's a project location in southwest Mongolia, 980 kilometers southwest of Ulaanbaatar. This is a tectonic geological map showing Carboniferous Permian arcs. The project's located in the new, Trans-Altai terrain of what's been termed the new Kazakh-Mongol arc. They are dominantly andesitic rocks, Devonian to Carboniferous, and they're intruded by Devonian to Carboniferous calcalkaline granitoids. This is a project map. The area, whoop, I have fat thumbs. Okay. The area we're going to be concerned with is in here. The Discovery Zone is located in this area. Discovery Zone in the Union North, the 2 small resource areas. There are 2 packages of volcanic rocks at Altan Nar. One we call Sequence A. This is basically in green. They're trachyandesitic rocks. They're intruded by fine-grained granite, dikes or sills, and the latest is a granite porphyry. We believe the rocks are fairly steeply dipping, but the outcrop is very poor. These are all intruded by a coarse-grained peralkaline granite. Within the Altan Nar area, the green represents andesitic rocks, and the light green in here are volcanic breccias. Strong northwest lineation in package A. Very little lineation or strike can be mapped in package B. The area is cut by 8 versions of dikes, generally taking an east-west or a north-south trend. Whoops. The wrong button. There we go. Alrighty now, that's how the day's gonna go. All right. So this is a reduced pole magnetic map. Basically, the granite is non-magnetic. Sequence A volcanics are well expressed as high magnetic relief, about 1,500 nanoteslas. The highs correspond with the trachyandesitic rocks. The lows correspond with the granitic, fine-grained granites and the granite porphyry. You can see strong indication of that northwest lineation. Within Altan Nar, we really don't see a lot of trends. Basically, some small segments, blocky, fairly large areas of low magnetic relief, which is typical and known to be caused by magnetite destruction. This is a view of the area of a Voxy model looking from the northwest, and this demonstrates the relationships we think we understand. The granite on the northeast. Sequence A volcanics appear to be underpinned by the granite and intruded by these granitic dikes. And along the western edge, they appear to be steeply dipping in underneath these package B volcanics. You can see they just kind of appear to wrap around that pluton, or the granitic body, as if they're domed and intruded. And this begs the question of which way is up in this system. Okay, from 2009 to 2011, the sequence of events, this was grassroots discovery from a regional exploration program targeting Paleozoic terrain. Resulted in discovery of a small copper showing along the granite contact called Nomenthal. That created follow-up soil geochemistry survey, rock chip mapping. The soils delineated a broad lead-zinc soil anomaly, 5 by 2 kilometers. That was followed up with IP, resistivity, and ground magnetics, and a 4-hole test. This is the soil geochem. Built. My thumbs are too fat. Gold, copper, lead, zinc. 50 ppb upper limit here, 200 ppb upper limit here, 300 and 500 ppm. This ppm. Broad zone of lead, zinc mineralization with gold. Okay, so this created an orientation survey. Area we're going to look at next is in a 1 by 2 kilometer block, and with some dipole-dipole lines. We're going to look one dipole-dipole line. What's showing up here now, unannounced, are the outlines of the small resources that have been defined so far, and these will show up on subsequent slides. This is a dipole-dipole line run across the target A. Basically a classic pan leg response. These are 50-meter dipole-dipole, 50-meter depth ticks on the side. Basically, in all my slides I'm going to show resistivity as reds, and low resistivity as reds, and high resistivity as white. This goes from about 300 to 3,000. In the area of the anomaly, basically just a gradient in the resistivity. Weak reduction in resistivity there, but not much different from anything else. A pretty good defined IP anomaly, kind of strange looking in 2D. and basically occurring within a broad diffuse zone of IP response. And we'll learn later that this is because we're basically at a low angle to target. This is the gradient array survey, 100 meter line spaces, 25 meter dipoles, 1 by 2 kilometer, 4 drill holes targeted on the anomaly. We've got strong northeast, north-south, and the initial test on an intersecting structure produced pretty good intercepts. These are projected to surface intercepts greater than 1 gram per ton. This is what the property looks like. Pretty easy, pretty flat, total of about 50 meters of relief. This is the breccia. It's an epithermal sulfidic breccia that was hit in the first hole, the discovery hole, returned 55 meters, 1 gram per ton gold. In addition to breccias, we see classic banded epithermal veins superimposed. The mineralization is a complex ore, multiple phases of brecciation silicification. It's near vertical structural control. It has manganese, iron, and calcium carbonates in various proportions, abundant fine coarse-grained galena and sphalerite. And the gold mineralization occurs within broader zones of base metal mineralization. And the philic alteration quartz sericite iron halos. This is from the RPM resource. It shows a typical section through the discovery zone and basically shows the upward flaring geometry, and that the base metal lodes are on the left and the gold lodes are on the right. This is the same section and demonstrates that the gold occurs generally within the base metal lodes, giving us a wider target. This is a histogram log of the mineralization in the discovery hole. And basically to show the gold shown here occurs within a broad zone of zinc and lead mineralization and a broad zone of pyrite that's larger than the gold, which gives a difficult target a chance to be detected. This the discoveries led to an expanded gradient array survey. This is about 16 kilometers. Here's the discovery zone and what's known as the Union North. We see are strong northwest trending IP anomalies. This is about 8 to 16 milliseconds. Northwest trending is associated with the contact along the sequence A and sequence B. And within what we call the Altan Nar trend, basically a series of narrow IP anomalies, highs, some of them riding on broader zones, which gradient array can be looked at sort of like magnetics. Narrow features give sharp anomalies, deep features give broader anomalies. We see that the highest portions of these anomalies tend to line up northwest, almost look an echelon, led us to believe that these may be related to dilational features in a dextral shear zone along the contact between the A and B volcanics. The resistivity, basically a lot of structure, highs and lows. We see a break between generally north-south, between lower resistivity and highs. These high resistivity zones were drilled are early stage, massive silicification, non-gold bearing, but the edges of them are found to be places of more dilation and tend to open up and create more grade. Here on the left, I've just shown drawn the line, so if you couldn't see the targets, see, again, a couple of these areas, in particular these two, show evidence for shallow features overlying deeper zones of sulfides. We followed up, we're zoomed in onto a smaller area now. After the main discovery, we expanded the grading array, and then we did some dipole. The upper half was just completed last spring. So this is 3D inversion of the dipole data. Sliced at two elevations. The top is 1,300 meters. At Union North, the elevation is about 1,325, so it's about a half a dipole down. At same here, about 1,325, and then in this area it's about 1,310. So the 3D survey inversion has tightened up in the shallow parts of the system. It's given us pretty good definition of the mineralization. The highest anomalies are in known mineralization. We've also got targets here and here. This trenching here has returned 9 grams of about 9 meters of 1.5 grams. So these are all showing up to be mineralized. The resistivity doesn't really provide a lot of anomaly yielding here at the Union North. It does give us a better indication of structure controlling the Discovery South. This is the 1,200 meter elevation, and now we see that we've gotten through a lot of the surface chatter, and the Union North resource lies on a pretty well-defined northeast trending gradient, and pretty good, gradient on the Discovery Zone. What we see here is in the area where we had evidence of deeper sulfide mineralization in the gradient array, we do indeed see large anomalies at depth, relatively speaking. And then Union North ties to some drilling that was done down here that hit some mineralized intercepts. We're going to look across a short section across Union North that was extracted from the 3D model, and I think I'd learn. This is the gold resource surfaces, loads provided by RPM, steeply dipping to the west, occurring within generally this low resistivity layer. But here's the deeper gradient and evidence of a low resistivity zone off to the west. As you can see, the mineralization has a strong correlation with chargeability, and there's a hint of the westerly dip. This is a 3D volume over the Discovery Zone mineralization produced with the 11 millisecond chargeability contour, and just demonstrates the relatively close correlation to mineralization. And also we're at a fairly low strike to our lines, and while this isn't a 3D survey, the 3D inversion has actually done a reasonable job of pulling out how things line up. This is mineralization at the south bow at the end of the large deep anomaly. So this is some ground magnetics. And lots of highs and lows and in between. This is the reduced pole. This is 25 meter north-south, 25 meter east-west by probably 1 meter sampling. Alteration lows associated with the mineralization at both deposits. A lot of fine structure. There's still quite a bit of magnetic relief in here, and we see some indication of very narrow linear lows. Strong east-west or northeasterly trends in lows intersect at these locations. These are reversely magnetized dikes, positively magnetized dikes. There's a lot to be done with looking at the relative offsets of these with the magnetics. Large area of alteration here. This is very typical of magnetite destruction in epithermal systems. You get flat areas. You may have deeper anomalies showing up underneath them, but the surface relief or the surface character has been flattened out. First vertical derivative basically giving us a lot more structure, seeing a lot of narrow things, lots of things to look at. Northeast trend coming through the discovery zone. These dikes are following some of them. One of the things that I've found really helped here is the tilt derivative of the RTP. That's sort of akin to the first vertical derivative. Has the same polarity. Lows are lows, highs are highs. On this map, the gray areas are lows and correspond with mag lows. So it's also really good for seeing different characters of magnetic response between different units. This is a block of the A series volcanics faulted into the B series. One of the things that I've found particularly useful here as well is taking the tilt derivative and superimposing it on the chargeability from the gradient array. So this is the gray, is the tilt derivative. This shows the drilling that has been done in the Discovery Zone and Union North. And this is the Union South area that's being drilled. This would be known as the Riverside. This is our North Bow project. It's untested. So what I've done here, I've taken the holes off. Hopefully you sort of remember where they are. I've added gold equivalent of 20 grams per ton, and showing that the higher grade is 20 grams per ton or greater, shown as black. So when I show these, you're looking at the lower cutoff of the interval. The highest grade intercepts are at some of the highest chargeability values. And we have to remember this is steeply dipping. I'm going to give it a little slack for not being right on that low. But it is in the chargeability high. But these narrow lows in the mag with corresponding increases, direct increases in the chargeability turn out to be pretty important. So here's 10 grams per ton. Start to line out these trends here and show that they're accumulating on the intersection. There's 8 grams. We've got one popping up down here, not low. Here's our Union South mineralization. 4 grams. 2 grams. And we got this guy showing up. And we've got what we know call our Maggie project. A very, very subtle IP anomaly. One thing I forgot to mention was, these anomalies are less than 10 milliseconds in these peak of amplitude, so they're quite subtle. You've got to have really good IP data to do this. There's the 1 gram per ton, and now we're starting to see the mineralization associated with the riverside. Again, trenches across here have returned a 9-meter intercept of 1 gram, 1.5 gram gold, 0.25% zinc. Clearly a mineralized, completely untested system. I was worried about how well that slide was going to show up, so I just made one without all the gray on it. And with the holes all greater than 2 grams per ton on the chargeability. So obviously I think the chargeability is really important in this project. So to summarize, this has been an integrated exploration program. It was focused on shallow, bulk mineable targets. I forgot to say at the start. Less than 100 meters. So the geophysical characteristics of mineralization, mineralization is highly correlated with chargeability, and particularly on northerly and northeast intersections. Magnetic lows and quiet zones indicate magnetite destruction of the normally magnetic volcanic rocks. Narrow lows in the ground magnetics are significant in terms of structure, albeit often narrow structures that are hosting mineralization. And coincident tilt derivative lows and chargeability highs are highly prospective. Beyond the 2 resource areas, multiple target zones over 6.5 kilometer area have returned very high percentage of mineralized intercepts from scout drilling. 14 of the 27 holes that were drilled to test coincident geochemical and geophysical, predominantly chargeability targets, hit at least 0.5 gram of gold over 1 to 19 meters. So almost all of these are mineralized. And that's it.
Okay, we have a little bit of time for 1 or 2 questions.
How many grading blocks?
About 19. They're laid out in 1 kilometer blocks.
And these things must be high. How are the merges on the blocks?
The merges were good. That's one of the reasons I keep the block size low. And the dipoles were 3 kilometers. Typically like to work within the central 3 kilometers. That helps a lot with merging issues. It took very little shifting to
Maybe you
move.
kept the thing for a while outside the block.
Yeah.
Jeff, what code did you use for 3D inversion?
That was the Geotomo Loki's code.
Can you explain tilt derivative a little more?
Okay, tilt derivative. That's the ratio of the first vertical derivative to the total horizontal derivative. And it's the arc tangent of that ratio. So it's measured in radians. One of the things that it's good for is, because it's in radians, you can only take minus pi over 2 to plus pi over 2 values. So it's very useful to for tracing structure through areas of very high magnetic relief or differing magnetic areas. So whereas in a regular magnetic map, you go from low to high, you might not see this little subtle structure crossing between it. So with the tilt derivative, it kind of flattens everything for seismic guys like automatic gain control, basically. It allows you to see continuity of structure. And I've never really used it much, but here it's really interesting. Did that help?
Yeah.
You want me to draw you a
No.
formula?
Do that over there. Okay, thanks very much.